Take a look at this setup in the AWS console. There will also be a step-by-step for setting this environment up yourself if you want to follow along in the demo files. A very similar setup to Azure, but it looks a bit different. The EC2 instances are small Linux machines running Ubuntu. In a similar way, they're hosting the Juicebox application on port 80. In AWS, you then need to ensure their security group allows access from other applications in the same security group, and then put the EC2 instance into a target group. Registered as part of the target group with port 80 specified, you can then point the load balancer at this target group when you build it. The load balancer provides the external URL that will be redirecting the HTTP request to the target group. And the Integrated Services tab shows the web application firewall currently enabled. This is, however, a separate service that has to be provisioned outside of the application load balancer and then associated with the ALB like you see here. The rule sets have a few more options than in Azure, but once again, you can find the OAuth's core rule set here as well. And you can see it implemented along with some of the other rule sets like those for the Linux operating systems, SQL databases, PHP applications, and more. The web application firewall has a limited number of slots for rules, and each of these fills up some of those slots, so you can't really just choose all of them, but instead, you have to be more selective and spread out your application load balancers across unlike technology stacks. In the overview section, you get a graph with a list of rules that have been triggered and a bit of data about it. But if you notice, the information provided here is not very helpful, and this will only display the last few hours. If you want to get more granular, you can move over to CloudWatch, though this is more specific to metric monitoring and less security analysis. To properly monitor the web application firewall, I had to set up a Kinesis data flow and link it to the WAF and dump that data into an S3 bucket. And you'll see that in a moment, but first, let me show you how a local file inclusion vulnerability can work on this application. This application allows the user unauthenticated to browse to a directory called FTP. Now, just because it's called FTP doesn't mean it's running FTP, but it does contain files that seem sensitive to the company or at least to the owner of the file. This is in the most basic sense a local file inclusion vulnerability if these files were not intended to be exposed. However, it seems like it may be more intentional than previously thought, because if I click on Easter year GG, I get an error that tells me that only files with the extension .md or PDF are allowed to be downloaded. Now, the developers may have thought that the way that they implemented this provided some decent protection, but crafty adversaries and researchers have figured out that the use of what's called a null byte or poison byte can subvert a filter like this. I'm not sure what this file is, but the package.json backup file looks like it may contain some information an adversary would be interested in, though the extension is .bak. So the same filter is applied. And in the URL, you can see to get the file, all that has to be done is to add it to the URL. But the .bak extension not matching is the problem. So I'm going to add a URL encoded null byte with the approved extension .md and see if that helps. Well, this time I'm instead getting a bad request error, but there is always more than one way. I can still try the URL encoding for the %sign so that it will properly pass the %00 to the filter. And I'm in. That was a pretty blatant file inclusion, and if I check, I did get some alerts on that URL, but not the URL that I used to bypass the filter. Without a lot of fidelity into the rules that fired and how they work, it's hard to know if the attack would be detected or not. So instead, I'm just going to enable every single rule in protection mode, or with the block action here in AWS, and try the exploit again. This time when I browse to FTP directory, I'm instantly blocked. Uh-oh, looks like I broke it. This is probably not the intended function, and though the dev should not have named the HTTP browsable directory FTP, that is indeed getting caught by one of these rules. But either way, I shouldn't break the function, so I can't block the entire directory. But what I could do is enforce that it's working the way that it's supposed to and get detections for anyone trying to do otherwise along the way. In the AWS WAF menu on the left, there's a regex pattern set section. Here, you can create sets of PCRE regex patterns that can be used in custom rules on the WAF. Because the WAF looks at the entire URL, I can create a blacklist of files that should not be downloaded, and in the meantime, let the devs know that they shouldn't store those files there. The blacklist is required here because the exploit still uses the .md or .pdf extensions, making a simple whitelist a non-starter. I create a custom rule using the test regex pattern that was just created and set the action for this rule alone to block. And now when I attempt to exploit this again, regardless of how I format the poison byte, I can no longer download this file. To see the detections from this rule specifically, we have to analyze the WAF logs. The way I have it configured is to dump the files into an S3 bucket. I can download the files from the S3 bucket and deal with them however I like. There is a module to parse AWS logs into Elastic, but there are only a few entries in this log, and if you follow the log, you can see the rule triggered was indeed the custom test rule. The action taken to block the request, the type of request and associated UIP data for the country, and the URI that includes the %2500 poison byte. And that is a positive detection. Getting all this set up is great experience and also a really good way to see what kind of activity you find when a vulnerable web page is hosted on the internet. There are research groups that have a number of these set up to identify current emerging exploits, but think of that from a red team or adversary perspective. They, of course, have the same thing going on, waiting to see what other groups and other exploits are ran so that they can have first access to any of these new 0 days. Just something to think about.